Okay, so finally, we're going to look at interpreting the predictors in logistic regression, trying to see which of those factors are going to help us to differentiate between who becomes a metahuman and who stays a regular human. So the way that these predictors are evaluated, first of all, is using what's called the Wald test, probably named after somebody whose last name was Wald. And the way this is calculated is b squared. So b is the mysterious values that the computer created for us that help fit the data, and of that particular value, and then it's divided by the standard error, or so it's the beta weight squared divided by the standard error of that same beta weight also squared. So to do this calculation, it's not that hard. So let's choose our distance variable. So for our distance variable, we have the b value, which is this negative 1.07, which you should know indicates that the distance variable actually had a negative, is negatively related to our dependent variable. So being closer to the blast actually increases. So having lower mileage increases the odds of becoming a metahuman, which makes sense. The closer, the more likely you're going to encounter the blast. And so that's why that beta is negative. And so all we got to do here is, so we got our beta values there, and then there's the standard error. That's what SE stands for, of that beta value. And so 0.39. And so we're going to square those. And if we square them, we get 1.14 divided by 0.154. If we divide that, our Wald value is 7.39. And just like we did with chi-square, you can find the Wald chart and find out at 1 degree of freedom what the p-value would be for a Wald value of 7.39, like we have here. So that's the first way, and so that's the way we make sure that those beta values are significant from 0, that they add sufficiently to the model. If this p-value is above 0.5, we would say no, this particular variable is not sufficiently adding to that model, and so so we could just leave it out. And actually, I found that SPSS, when calculating the effects, actually does leave them out in the prediction equation if you don't if the p-value is above 0.05, which is, I don't know, just a little tidbit for you. So and then the other thing, and so once we've determined that these, and you can see both these predictors are below 0.05, and so they do sufficiently add to the model, even if the R squared font really wasn't that much at the end. But we also have another way that we can interpret these predictors is using odds ratios. And so this is kind of cool because odds make a lot of sense and people understand odds. Like, what are the odds of this happening? What are the odds of that happening? And really, it's kind of a cooler uh, way to talk about an effect size, even than compared to multiple regression. It's just a lot simpler. And so you can use these values here on the right are the odds associated with each predictor. So based on this, what you could say is controlling for the effective energy. Remember, whenever we do multiple regression, we're always controlling for other variables in the model. Every mile away from the blast reduced one's odds of becoming a metahuman by 0.34. And so, and you could even say, like, if it was 10 miles, you're 10 miles closer, your odds would increase by 3.4. If you're 100 miles closer, you get the idea. You would, and so that's how the effects go. And so you have, the further you were away, the less odds that you have of becoming a metahuman. So don't want to be close to the shock wave if that happens. So looking at the distance, the energy variable, which was whether or not they were in touch with some type of energy at the time of the shock wave, like our buddy Hodling was, in which when he got struck by lightning. we can look at this odds ratio right here, and you can tell, and it's important to make sure that this is interpreted correctly because this is a categorical outcome. So there's no 0.24 energy, it's 0 or 1. And so when you have this particular variable, you want to make sure it's interpreted correctly. And so this one's positive. And so what you would say is in this scenario, controlling for the distance from the blast, citizens who were in contact with an energy source, like a lightning strike, were 1.97 times more likely to become metahumans. And so almost twice as likely if you were messing around with your car battery or getting struck by lightning or something like that at the time of the shockwave blast. And so that's an increase in odds. And so one of the cool things about using this for research, I think, is it's so easy. It's just easier to explain. And you could say you're twice as likely to get polio if you're 10 times more likely to get a particular disease if you haven't been vaccinated. People understand that, and it makes sense. And our buddy Dr. Wilt says, okay, that makes a lot of sense. Let's use it. Let's go find some metahumans. And so there you have it. There's kind of all we're going to talk about for logistic regression for now.